All right, here are the answers to the free response that you took on Monday. First, I want to say that I am proud of you, that you're brave, that you did your best. I know you did. Sometimes it works, sometimes you remember, sometimes you don't. But let's go through and see. Maybe you got more right than you think, and it wasn't maybe as bad as you. Let's still make it a learning opportunity, right? Even if we didn't do good. But I know you did well. I feel good that a lot of you did better than you thought. All right. And number one, it's a table question. Temperature of coffee is there. It's important to know that this is not a rate. It's just the temperature at each time. And in A, it says approximate the derivative at 5. They even tell you average rate of change. They've never done that before. So for these table questions, they would just say approximate the derivative at 5, and you'd need to recognize how to find the slope around that point. So how would I do that? So on your piece of paper, write down number 1. So this is A. And you don't have to simplify, but you have to write down what you're doing. So the derivative at 5, and it's 69 subtract 85, and 7 take away 3. If you did simplify this, the answer was -4. Now, it also says, hey, write down the units. And so the units is degrees per minute. Probably 1 check mark, but I'm not sure. They haven't released how they are scoring it yet. Part B says, use a left Riemann sum with the intervals given to find this value. So write this down first. I'm integrating from 0 to 12. You don't have to simplify it. So it's 3. That's the width. The width of the first one's 3, and then left means use the left height. So it's 100. Plus the next width is 4, and the height is 85. And then the next width is 5, and the left height is 69. Then it says, a second part, interpret what this means. So do you recognize what that is? Another way to write this, if you recognize, is when you integrate and then you divide by the difference of the bounds. It's the same thing. What does that mean? And so this is the average value. In this case, this is the average temperature. So that would be the average temperature of the coffee for the first 12 minutes. Part C. I haven't even used my calculator yet. Part C, from 12 to 20, I will have to use my calculator here. The change of temperature is modeled by this derivative, where that derivative is measured in degrees Celsius per minute. Find the temperature of the coffee at T equals 20. So first I need to know, at 12, what's the temperature? So at 12, the temperature is 55. So that's the temperature I'm starting with. Then I integrate the derivative that you're given, and I integrate from 12 to what I'm looking for. So it's 12 to 20. And then you would type that in your calculator, and the answer you would get is 40.329. And that's degrees Celsius. That was the average temperature from 12 to 20. Not the average, sorry. That is the temperature at 20. So at T equals 20, the temperature of the coffee is now 40 degrees Celsius. D. In D it says there's a second derivative for 12 to 20, and determine whether the temperature of the coffee is changing, decreasing, or increasing. Now, what I recognize is if you plug in any number from 12 to 20, so if I plug in 12 to 20, both the numerator and the denominator for all of those numbers are positive. So what we can say is the second derivative is greater than 0 for all values from 12 to 20. Therefore, the rate is increasing. That was it. That was number 1. All right, number 2. In number 2, this is a PVA question, position, velocity, and acceleration. So the first thing you should do is put that in your calculator. So I'm going to do that and show you what that would be. So let's see, it might even already be there because I did this earlier today. Clear up. Let's see. There it is. So put it in your calculator, then press enter. I did that already. So then when you need to calculate it, it's ready to go. So for part A, it asks, there is one time in this interval from 0 to 2 where the particle is at rest. Find that time, and then is the particle moving right or left from 0 to that time, and give a reason for your answer. So to know when it's not moving, you take the velocity equal to 0 and use your calculator. So first you'd write down what you're doing, the velocity equal to 0. Then with your calculator, you would go menu, I know, why it's getting all shiny, algebra solve, and we labeled it as f1 at x equals 0, comma x, control enter, and then it gives you 2 answers, but it's the answer between 0 and 2. So the second answer, no, the first answer, which is 1.425. Then the question is, which direction is it moving? Now for that, I want to look at the graph. So when I look at the graph, so you can see 1.425 right there where the first time it crosses the x-axis. Is this above or below coming there? So from 0 to 1.4, you can see the graph is above. The velocity is positive. So what direction does it go when the velocity is positive? So since the velocity is positive from 0 to 1.425, the particle is moving right. Part B. Find the acceleration. So how do I find the acceleration? Is I take the derivative. And they want you to find the acceleration at 1.5. So in other words, you're going to find the derivative at 1.5 with your calculator. So to do that, we're going to go menu, calculus, derivative at a point. So we used x, and then just f1 at x. And the acceleration is -1. And then it says, is the speed of the particle, increasing or decreasing at that time? To know if speed is increasing or decreasing, we need to also know the velocity at the same time. And we need to see if the signs match or if they don't match. So we said the acceleration's negative. How about this, the velocity? So the equation is the velocity. So I just need to go f1 at 1.5, and I get the answer -0.076. So -0.076. And what do you notice about the acceleration and the velocity at 1.5? They're the same sign. So that means the particle is speeding up, since both the derivative or the acceleration and, right, and you could say have the same sign or they're both negative. That's how you know. All right, part C, it says the position of the particle at t equals 1 is -3. Find the position at 4. So the initial position is -3. So I'm going to write that down. Plus, and then we integrate the velocity from, so at -3 it's 1, and what I'm looking for is 4. So 1 to 4, the velocity, and then type that in your calculator. So that's going to be, so -3 plus, we're going to go menu calculus integrate. And again, that goes from 1 to 4. And it's f1 at x dx. And I get -2.802. Part D says to find the total distance that it went. So total distance is the absolute value of velocity. So we're going to integrate from 1 to 4 the absolute value of velocity. And that's it. That's how we find the total distance. So to do that, again, menu calculus integrate, and we're going to go from 1 to 4. And then the absolute value, and I just type in f1 at x dx, and then control enter, and you get 0.958. All right, number 2 is done. No more calculator. Put that thing away. Now number 3. In number 3, this is a DiffyQ. So in number 3, you'd answer the first one right here on this. The depth of the seawater is given there, and you can see the differential equation there in terms of the rate of that is given. And then it says you're given a part of a slope field. Can you sketch a solution through 0, 4? So here it is through 0, 4. Just follow the slopes. So you can see how to follow the slopes, and then down through it, and then you can have your sketch your solution there. It says from 0 to 5, it can be shown that h at t, that's the solution you curved, when it's greater than 1, find the value from 0 to 5 which it has a critical point. That would be the one where it has a turning point. So like you can see that this thing curves. It curves pretty close to 3, but it's not exactly 3 because you can see it's a little slanted, but it's close where there's a turning point there. That's what I'm looking for. And it says determine whether the critical point corresponds and so on. So it can be so find the value. So I'm only looking for the value of t that gives me a critical value. All right, so I'm going to start with, here's number 3. So we already did A on the slope field. All right, so here's your DiffyQ. To know if there's a critical value, take the derivative equal to 0. And so what value? So obviously when h equals 1, but we're looking for actually what t equals. So we're not looking for h. And so I need to know what number would I plug in for t that would give me the answer 0. So we need to know our unit circle to know the value of cosine at pi over 2 is equal to 0. And then 0 times whatever, the answer is going to be 0. So if I plug in pi for t, this whole thing is going to be equal to 0. So what value is there a turning point? And that makes sense because pi is like 3.14 or so on, that it's very close. And you can see, yeah, that lines up to my solution curve, that it's 3.14 or pi. So we found where that is. Then the question is it what is it? Is it a relative max or min? And it's a relative max off the solution curve. There's other ways to show it, but I would be satisfied to know by looking at the solution curve that you could see that's a maximum and not a minimum by looking at the solution curve and you found the t value where it occurs. C. The curve intersects, no, I'm looking at the wrong one. Part C, oh, this is one that has so many points to it. I hope you got a lot of points here. So can you separate, integrate, solve for H, solve for C, so on? I think you could. Let's see how you did. Okay, so step one is we have h and t. So I'm going to divide only by h minus 1. So I'm going to divide h minus 1. That leaves me with 1/2 over here. That leaves me with cosine over here. That leaves me with t divided by 2. And then I'm going to multiply by dt. So now the h's are on one side and the t's on the other. Can you integrate this? The left is a logarithm. The right, the hook, the number you don't see there is 1/2. So the derivative of 1/2 t is 1/2. So that hook is the right hook. I don't need to adjust it. So the antiderivative rule for cosine is sine. And then you copy. And then plus c. So there you go. That's probably worth 2 points. The next step is we're going to plug in the point that's given. So it's 0, 4. So h is 4 and t is 0. Now 0 divided by t is 0, and the value of sine at 0 on the unit circle is 0. So sine is just that, ln 3. So 4 take away 1 is 3, the absolute value of 3. Now I know what c is. Then I go back into the equation, and where there's c, I put in ln 3. And then to solve this, it's just e to all of that. And then that's all in the exponent, and then you would just add 1, and that's it. So h is equal to this plus 1, and you have the answer. All right, number 4. Halfway there. Number 4 is a graph question. We had a table question, we had a graph question, we had a diffie-q. I don't know if there's a rate story. I think that's one they didn't do. Okay. So you have a graph. You're told what this area is. The area of that is 12, and that this is a line. So these are triangles. And then you have the function defined as this. So let's write that down. So for part A, g at x is equal to the integration from 0 to x, f at t dt, where f is the graph. All right. If you want to find the value of g at -6, plug in -6. And the first thing I recognize is the bottom number, the bottom boundary limit, is bigger than the top one. So from 0 to -6 is the shaded area, which is 12, but because the bounds are flipped, where the bottom number is bigger, that answer, we just do the opposite number. So instead of 12, the answer is -12. That's probably one check mark. G at 4, plug in 4. So what's the area from 0 to 4? This is what it says. It's that triangle, half the base times the height. You don't have to simplify it. So the base and the height. There's another check mark. And then the last one was 0 to 6, right? So plug in 6. And again, we don't need to simplify this. So we already have that. And then, so that's the one above. And then we have this triangle down here, and the base and height is 2 and 1. But it's a -1, right? Because it's below. And that's perfect. You could simplify it, but you don't have to. So that triangle above, subtract the triangle below. Part B. For the function defined in part A, find all the values from 0 at which the point g has a critical point. So we know it has a critical point when you take the derivative. So first of all, if I take the derivative, when you take the derivative of an integration, they cross out and x plugs in. It's just f at x. Make it equal to 0. So off the graph, where is it equal to 0 are the x-intercepts? And the answer is there's only one x-intercept, and that's at 4. That's it. And the reason is here, right? You say your reason in terms of it. The derivative is equal to that. And it's a critical point if it's equal to 0. And where on the graph is it equal to 0? And it's done. Part C. You're given h at x equals the integration from -6 to x of the derivative. Before I go on, I'm actually going to simplify this. So you already have a derivative and, integration and a derivative. And so the integration of that is just f at t, and then you plug in the upper bound, subtract the lower bound. So we already have that as an answer. So when I integrate a derivative, what's the antiderivative? It's just f at t. And I plug in the top bound, subtract the bottom bound. now we can answer the question. So the first question was h at 6. So then we just plug in 6. So off the graph, what's the y coordinate at 6? It's -1. What's the y coordinate at -6? It's 1/2. You don't have to simplify it, but it's -1/2, 1.5. The next one is the derivative at 6. So if I take the derivative here, let me do that below. What's the derivative of this? So the derivative is just f prime at x. This is just a number, so the derivative of that constant 0, so it's just that. And so what's the derivative at 6? Looking off the graph, the derivative at 6 is the slope of that line. So it goes down 2 and to the right 4, or -1/2. And then the last one is the second derivative. So the second derivative of f is also the second derivative of h. They're together. So if I want to know the second derivative at 6, I'm looking for the second derivative at 6, which is what's the concavity? Does it smile? Does it frown? Or is there no concavity? So if I look here at 6, it's a line. So the concavity here is there is no concavity. So if there's no concavity, we say that the answer is 0 because it's a line. And that's it. Number 4 is done. Number 5. This might have been like the quirkiest question, but who knows? So you're given an implicit situation, and you've already been told the derivative of that implicit situation. It says there's a point with an x-coordinate 3, and then use the tangent line at that curve to approximate it. So part A says do the derivative, do the tangent line. So we know that's x, y, and the slope. So you're given that the x-coordinate's 2, the y-coordinate's 4. To find the slope, use the derivative. So plug in 2 for x, plug in 4 for y, and then solve it. And then you have your equation. So it's -4/19 x minus 2 plus 4. Then we're going to plug in what they're asking for, which is the x-coordinate 3. We don't have to simplify this, but just plug in 3, and then you have your answer. You probably had 3 points there. To find the slope, maybe or maybe not. At least the tangent line, and then plug into the tangent line. Part B, it says, is the horizontal line y equals 1 tangent to the curve, and give a reason. If it's tangent to the curve, that means the derivative equal to 0. So I see the derivative. What would make it equal to 0? And there's only one answer that would make it equal to 0. So if I look at the derivative, what would make it equal to 0 is when x equals 0. Now it talks about y, but if I put in x equals 0, I have, if I put in x equals 0, this is what I'm left with, and you can see that there is no way y equals 1 here. If I plug in 1 for y, it does not equal at all. So this and this, you could see that is it, and the answer is no. And you can see that's the only value there, and when you plug it in, y does not equal 1. Okay, part C, again awkward. They give you the point root 48 and 0. Is the line tangent to the curve, is it vertical? And so to understand a vertical tangent, again, is to understand a vertical tangent means the derivative is undefined. So it's the denominator, which is 3 plus 4y. If you make it equal to 0 and solve it, you get y equals -3/4. So when you look at this, y is 0. So therefore there is no vertical tangent at y equals 0. So you have y equals 0, it's only at y equals -3/4. So when y is 0, there is no vertical tangent. All right, part D, I'll make space. Part D, completely different question than what you're given. You're given another equation, and you're asked for the rate of change with respect to time. So you got to take the derivative with respect to time. So y cubed plus 2xy equals 24. So the derivative here is 3y squared, but then it needs the hook dy by dt. This is the product rule. The first times the derivative of the second, it needs that hook, plus the second times the derivative of 2x, but it needs the hook dx by dt. And then the derivative of 24 is 0. And then in the question it has values to plug in. So it says the particle. So x is 4 and y is 2. So we know x is 4, y is 2. And then it gives me the derivative, the instantaneous rate of change of y. And it's decreasing. So the y-coordinate is decreasing at 2 units per pressure. So that means it's -2. And what I'm looking for is x. What's the rate of change for x? So I'm looking for dx by dt. So in other words, I'm going to plug in all that I know. So I'm going to plug in 2 for y. dy by dt is -2. X is 4. dy by dt is -2. Y is 2. There's another 2 there. And I'm looking for dx by dt. That's what I'm looking for. And then I'm going to solve this. So I'm going to do some mental math because I'm running out of room here. But this is 3 times 4 squared. That's 12 and -2. That's -24. This is 8 and -2. That's -16. So -24 and -16 is -40. I'm just doing mental math. I'm going to add 40 to the other side. I'm going to add 40 to the other side, and then I'm going to divide by 4, so the answer is positive 10. All right, one left. Number 6. So number 6, you're given a graph. I might answer it right on here. So number 6, you're given a graph. And you have 2 equations for f and for g. It says let r be this area from 0 to 2. It says write but don't evaluate an expression that gives the area for that area r. So we know it's top subtract bottom. So I can do that right here easily. So I'm going to integrate from 0 to 2, top subtract bottom. So that's f at x minus g at x. And that's it. You set it up. The second one is the longest question because it says let S right here be the region bounded by g in the x-axis from 2 to 5. And then S is a base, a solid base. For this solid, at each cross section, it's a rectangle where the height is half the base, and then find it. So for a rectangle, and I'm going to do that down here because I need a little more space. First of all, we need to know area is base times height, and that the base, in this case, is the top subtract the bottom. So g at x take away 0, which is just g at x. So if I think of this, it's g at x, and then the height is half of what that base is. So you have g at x, and then the height is half of the base, which is g at x. So if I put this together, it's actually going to look just like that, right? Because if you multiply it together, it's squared, and there's 1/2. That's going to help. Then we're going to integrate. So to find the volume, we integrate from 2 to 5. We integrate that area equation, which is 1/2 g at x squared. And then we're going to plug in. Now that 1/2 can go in front of the integration if it makes it a little bit easier. G at x, we're told, is x squared minus 2x. Now we don't have a rule for this. The hook wouldn't work here because the hook is 2x minus 2. I'm going to sneeze. Oh, I didn't quite. So I'm going to have to FOIL in order to do this. So x squared minus 2x, x squared minus 2x. So that's x to the 4th minus 2x cubed minus 2x cubed, and then positive 4x squared. And I'm going to come back here. We haven't integrated yet. So from 2 to 5. And I'm going to combine like terms. So x to the 4th minus 4x cubed plus 4x squared. We still have the 1/2 in front. And now I'm going to integrate. So I'm going to add 1 to the exponent and divide. I'm going to add 1 to the exponent and divide. I'm going to add 1 to the exponent and divide. And that's from 2 to 5. Notice the 4's cross out here. And then the very last step is just to plug in. Sorry, room here. I'll do it down here. So I have the 1/2 in front. I'm going to plug in 5 first. I don't have to simplify it. And then subtract, use parentheses. And then I'm going to plug in 2. And that's it. That is your answer for the volume there with the rectangle. Do not think you have to simplify that. Then the last question, part C, I can do right here because I just have to write an integral that gives the volume of the solid generated by, described by rotating. So now we know it's a circle if you rotate. So it's pi for part S. Again, it's going to integrate from 2 to 5. And if we go at y equals 20, there's a space between the line and the area that I'm doing. And so that space means there's 2 radii. So there's a big radius and there's a small radius. So the big radius goes from 20 to 0. And I can just do that. 20 to 0, that's the big radius. Subtract the small radius. And the small radius goes from the line 20 and then subtract the curve g at x. And that's squared, put parentheses, dx, and that's what it looks like for the volume, and it's done. Those were the 6 FRQs. Man, I know you may have not got them all right, but did you get some right? Did you get some points? Were you ready to go as best you could, right? I'm still proud of you for being brave. Mr. G Math, over and out till next time.